All right, guys, we are continuing our learning on equations. Last week we did adding and subtracting equations to solve for the variable. Today we are starting multiplying and dividing equations to solve for the variable. The first thing I want you to do is to solve the problems in the review. It says determine the unknown product or factor that make the statement true. So you are filling in the blanks with the correct number. Any questions? All right, you have about 4 minutes. Go for it. In our fraction packet, we did something. One of the exercises showed us what we multiply something by to get 1. What do we multiply by to get 1? The reciprocal of that number. So if I want the reciprocal of 23/7, what is the reciprocal? That's all you're doing. And that will give you 1. Because the 7's now cross each other out and the 23's now cross each other out. And they all become 1, which equals 1. Does that make sense? So on number 1, I get 20/20, which equals 1. What would I multiply number 2 by to get 1? 1/5, because right now as a fraction, this is 5/1. And I know if I multiply by the reciprocal, I get 1. Yes? You're going to need to remember this later in the lesson. That's why I'm stressing it. When you multiply a number by its reciprocal, it equals 1. So, making this a fraction, they are reciprocal, so I know it equals 1. Yes? Any questions? All right, turn the page. We're going to review for a second. I don't like talking over people, guys. All right, this is exactly what we were doing last week. They give you 3 equivalent equations on the double number line. They want you to write the 3 equations that are represented on the double number line. They want you to find the value of n that makes the equations true. And they want you to check your answer. Any questions? 3 equations, find the value of n, check your answer. I'm going to give you about 5 minutes. Go for it. All right, who can tell me what the first equation that is represented on the double number line is? Riker? 2n equals 6. What is the second equation represented on the double number line? 4n equals 12. And the last equation represented on the double number line? How about 21? All right, 5. Let's talk about the values of n. 2 times what would give you 6? So n equals 3 for the first one. 4 times what equals 12? And 7 times what equals 21? Remember when we talked about it last week, I told you that if they're all in the same double number line, the value for the variable has to be the same. It cannot be different. So did we get the same variable for each equation? Yes, we got 3 for each one. Now we can check our answers. Does 2 times 3 equal 6? Oh, no. Yes, 6 equals 6, so it is right. Does 4 times 3 equal 12? Yes, 12 equals 12. And does 7 times 3 equal 21? Yes, 21 equals 21. Does that make sense? What other way could we check our answer? You can count. What did we do last week when we were trying to find the variable and we were adding in the equation? What did we do? We subtracted. We did the opposite. So what is the opposite of multiplication? Division. So can I do 6 divided by 2 equals 3? That gave me my variable, yes. Can I do 12 divided by 4 equals 3? And can I do 21 divided by 7 equals 3? So that works as well. What property of equality are we using when we solve it this way?
Inverse operation.
The division property of equality. Any questions about that? Good. Let's look at the next page.
Okay, today we're gonna take the next step. Last time we worked on addition equations. Now we're gonna do solving multiplication equations. It involves determining the value for the variable that makes the statement true. That's what a solution is. Okay, so if I have a multiplication equation such as 2x equals 6, this equation states that for some value of x, the expression 2x is equal to 6. So if I use my double underline, what we know is we have 0, and at 2x it equals 6. You can decompose the distance of 2x into 2 equal parts to determine the location of x. The expression 1x for x is halfway between 0 and 2x. Why are we dividing it by 2? Because it's 2x. Does that make sense? So that means there's 2 intervals because it's 2x. So if it was 2 intervals, and I decompose it into x, that's halfway between our 0 and 2x. So then I need to find the corresponding value that is halfway between 0 and 6. Does everybody agree that 3 is halfway between 0 and 6? Okay. So since the expressions are connected as an equation, you also need to locate the point that's halfway between 0 and 6. By examining the number underline, you can see that x equals 3. That is my solution, yes? So if I ask for a solution, and I don't have x equals 3 written on my paper somewhere, did I do the solution?
No.
What if it's on the picture? Have I done the solution? No. I have the information for the solution, but I have not yet written it. So let's do a couple more. We're going to use the double underline to decompose the distance of the variable term into equal parts to determine the location of x. You have 2 parts, identify and check your solution. Okay, so the coefficient should tell you how many intervals I need to break it into. The answer tells you what it is at the point where the coefficient lays. But I need to go back to where x is. Okay, so the bottom line is the coefficient tells you how many lines I need, but I'm asking you to solve for x. So we've got 2 problems. We're going to get about 3 minutes. Good, knock these 2 out. Again, your coefficient tells you how many spots I need to break it into. So for the 3x means I need 3 lines. So there would be 1, 2, 3. We have x and 2x. So that means I need 3 intervals to get to 12. So what would my first interval be? 4. Then we can check that. 4, 8, 12. Does that make sense? Yes. So what is my solution? X equals 4. Yes, you need to have that written down. Why? It said identify your solution. Then we also need to check it, meaning I put it back in. So 3 times 4 equals 12. 12 equals 12. Does that check? Yes. Again, my variable tells me how many, or my coefficient tells me how many intervals I need. In this case, I need 7. So 1, 2, 3, 4, 5, 6, 7. X, 2x, 3x, 4x, 5x, 6x.
Hush, guys.
So to break it into 7 intervals, what would I go to get all the way back to x? That would be?
What's 63 divided into 7 pieces, guys?
9. Let's check it. 9, 18, 27, 36, 45, 54, 63. Did that check? Yeah, so what is my solution? X equals 9. That should have been clearly identified. Then I checked. 7 times 9 equals 63. 63 equals 63. Check. Is this making sense? Okay? So let's try it again. And now we're going to switch it up a little bit. Multiplication equations often include numbers other than whole numbers. So if I have the equation 1/3 x equals 2, explain how the variable term in this equation compares to the variable terms in the previous activity. And I'll give you a bonus point if you use proper math terminology. Last class, they got a little piece of candy for using proper math terminology. It was. Guys, right now, can anybody explain to me using proper math terminology what is different?
Explain how the variable term in the equation compares to the variable term in the previous activity. We did multiplication property of equality and division property of equality.
Okay, but how is this one different? What's different here?
Where's addition and subtraction?
No. Guys, please, one at a time. No. Then? Oh, so close. If only you use right math terminology. What do we call that term before a variable?
Oh, coefficient.
Coefficient. Okay. So the coefficient is now a fraction, where in the previous problems it was a whole number. So big difference. You just changed the coefficient. Instead of a whole number, it's now a fraction. Now, there are different ways. When my numerator is 1, multiplying a coefficient by a variable with a numerator of 1 is the same as dividing it by the denominator. Okay? So if I consider the multiplication equation 1/3 x equals 2, the equation states that for some value of x, the expression 1/3 x is equal to 2. So I know at 1/3 of the x, my value is 2. One way to solve this equation is for x to compose 3 distances equal to the 1/3 x to create the distance x. Then to maintain equivalence, compose 3 distances equal to 2. So I've taken the 1/3 x, so that I would go to 2/3 x, and then I would get to x, correct? So if that first interval was 2, that second interval would now be at 4, so I would just add the 2. Then my third interval would be at 6, because I'm just adding. You've got to remember what my interval is. My interval is 2, right? So I'm not just doubling it, I'm just adding 2 each time. Make sense? Does everybody understand where those numbers came from? Do they make sense to you? Okay? So really what I'm trying to do is
Us guys.
get 2x. So what would my solution be?
X equals.
What does x equal?
No, where is X?
So my solution is x equals 6. But then we need to also check our solution. So to check our solution, we put it into our prior equation. 1/3 times 6/1 equals 2. I've got a reduction of 3 that I can do. 1 times 2 is 2. 1 times 1 is 1, which equals 2. 2 equals 2. Check. For those that don't like doing reductions, 1 times 6 is 6. 3 times 1 is 3. 6 divided by 3 is 2. 2 equals 2. Still check.
Why do we always have to do like interval?
Because this,
Why can't we like just go straight to one?
Because you can't skip one
I
another.
can't skip on another line. If I skip my intervals, then I don't know what that interval is. We set our interval at 1/3 x, yes? So every interval has to be 1/3 x. Once you set your interval on a number line, every interval has to be the same. Does that make sense? Okay. Questions on that page? Okay, let's go to our next one. So now you're going to compose the distance of the variable term into the appropriate equal parts to determine the location of x. Then identify and check the solution. So there's really 3 parts to this. You're going to compose the distances, you're going to identify your solution, and you're going to check your solution. I'll give you a big hint, guys. The denominator of my coefficient tells me how many intervals I need to be able to get to x. Okay? So you've got 2 to do there. And then if you finish that, go ahead and look at number 5 as well. See if you can start figuring that one out. I'll give you guys about 4 minutes. Go ahead and start. Okay, guys, again, my denominator told me how many intervals I needed. In this case, it was 4 of them. So I'm going to do 4 intervals. 1, 2, 3, 4. I know that my 1/4 x is 7. So my 2/4, I'm not going to simplify it, is going to be 14. 3/4 will be 21. 4/4, or x, would be 28. So I now have my solution. X equals 28. I needed to write that. But then we're also supposed to check it, meaning I put it back into my original equation. 1/4 times 28/1 equals 7. I can divide both those by 4. It gives me 7 and 1. 7/1 equals 7, which equals 7. So we have a check. For those who do not like doing reductions, 1 times 28 is 28. 4 times 1 is 4. 28 divided by 4 is 7, which equals 7. Yes, Ben. You like? You set out. Okay, my next one, again, my denominator tells me how many intervals. In this case, there's only 2 of them. So I have 1/2 x is 5, meaning that x would be 10. So here's my solution. I just need to write it. X equals 10. Then I need to do my check. 1/2 times 10/1 equals 5. I can divide both those by 2. 5/1 equals 5, which equals 5. So we have our check. We don't like doing reductions. 1 times 10 is 10. 2 times 1 is 2. 10 divided by 2 is 5, which equals 5. Make sense? Everybody tracking so far on how these work? Okay. So now we're going to throw in a little bit of a curveball. Vanessa used a double number line to solve 4/7 x equals 12. Analyze her strategy. She says, I created my double number line and represented the equation and x. So she had her equation, and then she also put x in. I labeled the bottom number line of numbers to identify the value of x. So why do you think she drew so many lines in here?
So in the grade, so like 6, 5, 7, 6, 7.
Because she needed 7 lines to get to x, correct? Because she didn't really get to x till 7, 7. But the nice thing about that is because she drew in all 7 lines, even though here is where she started, she now is able to say, okay, well, this is the 4th line, correct? So if I'm going to go back to the 1st line, I'm just going to divide them both by 4 to figure out where 1/7 actually was. Does that make sense? Then once I have my interval, now I know I'm just going up by 3s. Then you can go all the way up and see x equals 21. So why did she set the number up line this way? Basically explained it to you. You can say it back. Good. She needed 7 intervals because the denominator was 7. Then how did she choose where to put it? Excellent. So because the denominator was 7, I needed 7 intervals. She put it at the fourth one. Because the numerator was 4. So identify and check her solution. We got 2 parts. We kind of already identified it. I circled it, but we haven't written it to identify. But we can say x equals 21. We've now identified her solution, yes? To check it, we're going to go back to our original equation. 4 sevenths, not 47. 4 sevenths times 21 equals 12. I've got one reduction. I can divide both those by 7. 4 times 3 is 12. 1 times 1 is 1, which equals 12, which equals 12. Check. Those who do not like reductions. 4 times 21 is going to give me 84. 7 times 1 gives me 7. So assuming most of you don't know your 12 factors, 84 divided by 7 goes once. Gives me 14 goes twice. Gives me a 0. So you can see that this equals 12, which equals 12. Again, reductions just get you there a lot faster. Makes the math easier. But you can get to the answer even if you don't do reductions. Questions on this page? Yeah, let's try our next one then. Now, use Vanessa's strategy. See if you can do this. So you're going to solve each equation using the double number line and check your solution. Do not get messed up if I have an improper fraction. That literally just means I'm going past my variable in order to come back to it. But you can still use that same process. So use your double number lines, set them up. The denominator tells you how many lines to make. Numerator tells you which one it is at. There's 3 problems here, but then you also need to do a reflection. So I'll give you guys about 8 minutes. Okay, our first one, again, my denominator tells me how many intervals I'm making. So in this case, I'm making fifths. 1, 2, 3, 4, 5. So 1/5 x, 2/5 x, 3/5 x, 4/5 x, and then x itself. My equation is at the fourth one, and it says that spot, it is 12. So if the fourth one is 12, what is the first one? 3. Okay? And you check it because now I can, using that same interval, I can fill in the rest. So from 3, it's going to go to 6. Then I'm going to add another 3, goes to 9. 12, so check, that made sense. Had I done 6, did someone say 6? 6, my second interval would have been 12. Would that have been correct? No, you should have known right away that you were wrong if you had said that 6 was it. Meaning my next one is going to be 15. So I now have my solution, but I've not identified it. So I need to identify my solution. X equals 15. And we need to check it. So 4/5 times 15 over 1 equals 12. I can do a quick reduction. 4 times 3 is 12. 1 times 1 is 1. 12 equals 12, which equals 12. Check. Again, if you don't like doing the reductions, 4 times 15 is going to give me 60. 5 times 1 is going to give me 5. 60 divided by 5 is going to go once. 10 is going to go twice. So again, we get to 12, but we have a whole lot more work if you don't do the reductions up front, guys. Our next one, denominator tells me how many intervals. So I'm doing 4 intervals. 1, 2, 3, 4. So we have 1/4 x. I won't simplify it to keep it easy and make sure you guys understand that's 2/4. I know that I'm at the third interval. So my third interval equals 6. So if the third one is 6, what's the first interval? 2. We can check it. and my next one's gonna be 4, then it makes that 6. So that means x equals 8 is my solution. Go back to my equation substitute. Again, I have one reduction. I can divide both those by 4. 3 times 2 is 6. 1 times 1 is 1. 6 equals 6 equals 6. Check. Don't like reduction. 3 times 8 is 24. 4 times 1 is 4. Equals 6. So you can see either way, check. Our next one gets a little more intricate because they've got given an improper fraction, but I'm still dividing it into fifths. Garner, you've been gone this whole time. You need to be writing this stuff down at the very least, because I know you didn't do it. Meaning I'm dividing into fifths still. So 1/5. The problem is I need 8 of them. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 1/5, 2/5, 3/5, 4/5, then 5/5 or x. Because I gave an improper fraction, I'll continue as improper fractions till I get to my 8/5. At 8/5, I know that the value there is 64. So I'm now at 64 at my 8th interval. So what am I at the first interval? 64 divided by 8? 8. Let's check it. So we'll go up by 8. So we go 8, 16, 24, 32, 40, 48, 56, 64. That works. So my solution is where x is. So my solution is x equals 40. Go back to our initial equation. 8/5 times 40 over 1 equals 64. I have one reduction. I can divide both those by 5. Gives me a 1 and an 8. 8 times 8 equals 64. 1 times 1 is 1. 64 over 1 equals 64. 64 equals 64. Check. Again, if you don't like doing reductions, you don't have to. 8 times 40 is going to give me 320. 5 times 1 is going to give me 5. So now you need to take 320. You have to divide it by 5. Won't go into 3, goes into 32 6 times. Subtract 30 gives me a 2. 20 is going to go 4 times. Subtract 20. So you can see I still get the same thing. It's just a whole lot easier if you'll do the reductions here instead of having to do all of this. But it's your choice. So let's reflect on our equations from this one. How are all of these similar, and what was common in how I used the double number line? How are they all the same? Yeah? Fractions, okay. So that was common about how we solved them. But what was common about the double number lines themselves? And how did we set it up? How? What about the fraction? How did the fraction tell me to set it up?
With the amount of intervals.
How did I know? The denominator told me what? The denominator told me how many intervals. And what else did we use?
The numerator.
And that told me what?
Where to put it.
Good. So the denominator told me how many intervals to make. And the numerator told me which interval to start at. Okay. So one of the keys, how are they similar? They all have fractions for coefficients. Okay, we spent a lot of time using these double number lines to help you guys understand how to set these up. Because the hope is, once you are able to visualize what's happening, when we do that mathematically, it will make more sense. Is everybody tracking so far? Because unfortunately, we're down to about 8 minutes in class. So we do want to give you just a little bit of practice. So let's go ahead and go to page 492. No, this one.
Wait, hold on. Okay.
433. Okay, unfortunately, we don't have time. You guys get a lot of practice, so I am going to show you how you can just solve these algebraically. So instead of having to do the whole double number line piece, the good news is this goes back to what we gave you last time. So your setup is going to be the same. Circle your variable, draw a line through the equal sign. What's the opposite of dividing by 4? Multiplying by 4, but multiplication property of equality says if I do it to one side, I have to do it to both. Why am I multiplying by 4? Because now I have a 4 on top, 4 on bottom. So this is just 1 times n, which means that equals n. 7 times 4 equals 28. We're also supposed to, actually, oh, there it is, check to make sure it's true. So 28 over 4 equals 7. 7 equals 7, check. So we have our solution. Again, circle my variable. It's opposite of multiplying by 3. The opposite of time. So I'm going to divide both sides by 3. 3 divided by 3 becomes 1, so it's just y. 18 divided by 3 is 6, so there's my solution. We can check it. 18 equals 6 times 3 times 6. 18 equals 18. Check. Okay? What's the opposite of multiplying by 3/2? Dividing by 3/2. But we don't actually divide fractions. We multiply by the reciprocal. So instead, I'm going to multiply by 2/3. So I multiply both sides by 2/3. Why? Because these are all going to go away. Those become 1s, which means that's 8. On this side, I have a 2 on top and bottom. That gives me 5/3, which we would simplify to 1 2/3. We can do our check. We've already got the improper fraction, which is nice. So it's going to be 3/2 times 5/3 equals 5/2. Again, those go away because I got a 3 on top and bottom. 5/2 equals 5/2. Check. Here's my variable. The opposite of multiplying by 3 and 1/4, 3 and 1,400, is dividing by 3 and 1,400. Those go away. So 81 and 1,200 divided by 3 and 1,400. Remember, I need to get rid of my decimal and my divisor. So 314 is going to go twice. 8, 2, 6, 0, 2, 7, 8, 1, 8, going down to 1. 1,800 is going to go 5 times. So 25. Subtract 20, 5, 6, 7, 15, 1, 5, 2, 25 is probably going to go about 6 times. 24, 6, 7, 8, 18. We go 7 times. Oh no, that is even more than that. Sorry. 8 times. 32, 8, 11, 24, 25. Good call, Mr. Chan. So my solution is 25 and 8/10. So we're going to multiply 3 and 1,400 times 25 and 8/10. I've got 3 decimal places. Gives me 32, 11, 24, 25. 0, 20, 7, 15, 0, 0, 8, 2, 6, 2, 1, 15, 20, 3, 4, 6, 11, 7, 8, 3 decimal places, 81, and 1200. They check. Okay, we're going to talk the last two because we need to go to the homework. Go to 437. Okay, the journal on this one is a little tougher because we've skipped a lot of where we're going to use properties, but they're giving you a generic equation asking how do I solve for x? Your key here, include the properties. So show me where you start. I'll give you a hint. Use our process. Circle your variable. Show me what property I'm using to get the variable by itself. Number one has several parts to it. In all the parts, you're using the double number line to solve, and then you're checking. The coefficient is your key for how many lines I need. If it's a whole number, that tells me how many lines I need. If it's a fraction, my denominator tells me how many I need. Be aware, if it's a improper fraction, this means I'm going to have to go past my variable in order to solve for it. But my denominator is still telling me how many lines I need. Second part, solve and then check. Okay? And then word problem, make sure you show all mark the text because the second part basically tells you he doesn't have enough. Okay? Good luck, guys.